Hey guys, welcome to my channel. This is Kane. Today I'm going to introduce you a fundamental construct to our discipline, which is called computer algorithms. Computer algorithms are basically essential for this course, and I think they will be very beneficial for you to use in this course and in the further courses you're going to take up. Let's read through the official definition. A computer algorithm is a list of steps that you can follow to finish a specific task. As you can see from this sentence, there is no specific terminology that will be related to computing or mathematics. So essentially, you can use a computer algorithm for anything, to organize your life, to enhance your life experiences, or to basically schedule your routine. Such as you can use a computer algorithm generated to go to the airport from your home and look into which one would suit you the best in terms of time and money. So essentially anything that will be listed down instructively as series of steps can be regarded as a computer algorithm. When we look at the computer algorithms, you need to make sure that it is a step-by-step approach. This is a crucial point of computer algorithms because it should tell precisely what is going to happen in that step. It is essential to break down this into a very instructive way because at the end of the day, we are doing this to practice thinking computationally, and these instructions will be given to machines which they will need them to do to complete a certain task. When you are telling the computer devices to do a certain task, you need to be very precise. As I had given the example of computer algorithm before, you can generate computer algorithms to organize activities or to evaluate a certain pathway, to compare it with another, and so forth. For example, you can generate a computer algorithm to organize your gym routine, to see how much time you are spending at the gym or what kind of algorithm you should follow up to organize it to make sure that it works for you. Or you can actually develop an algorithm if a friend is arriving at the airport and visiting you, and they will be coming to your home and you are in no condition to pick them up. So it's like you can break down a series of steps such as a taxi approach, kind of like a call me and I'll guide you approach, a rent a car approach, a bus algorithm, and so forth. So each of these, as you can see, will lead that person from the airport to your home, and each of them will work, but there will be consequences. Now, this is the second important thing about computer algorithms. There are no right or wrong answers as long as you reach the destination, which means you go from the point A to point B. As long as you do that, there is no absolutely the most efficient way, but you need to kind of like sit down and break it down, like see which one works the best for that specific circumstance. Such as if you have the money but you don't have the time, then you can go for a taxi approach, because a taxi essentially works, it will go faster than a bus. And a rent-a-car could be another approach if you have even more money, or if your friend is going to stay here and they will need to use the car quite often. Or you can just simply tell them to use to tell your friend to use a shuttle service and then guide them through your address. So at the end of the day, all these approaches that you develop will work. The idea is to take that person from the point A to point B, but the consequences will be different. So when you develop an algorithm, you kind of like need to look at this, like you need to evaluate the approaches to see which one fits into the situation the best. In the next part, I'm going to discuss about the type of algorithms. You see in the at the introductory level, we have two different algorithms that we need to be fond of. The first one is called the pseudocode. A pseudocode algorithm is a text-based algorithm, which means it is written in an instructive English style, in a step-by-step approach, such as you say start, go to the fridge, open the fridge, take up the chicken from the fridge, put it into the oven, and just turn on the oven for 180 degrees and close the oven and stop. Something like this, something very instructive and in a very plain English style to tell step by step what needs to be done. That is called the pseudocode. A flowchart, on the other hand, is very, very similar to pseudocode, but it's rather using graphical symbols, diagrams to represent that algorithm. When we use these symbols, it is more practical, more understandable. If you know the meaning of the symbols, it will be easier for you to follow these steps rather than seeing them on a list. It might be visually feeding you more, or it will be very easy for you maybe to visualize it as you see the diagram. I personally prefer to start with flowcharts, and I would prefer to use flowcharts instead of a pseudocode because it's a very graphical representation. It helps me to visualize and breaks down the task. But at the end of the day, two approaches that we have here, both of them are quite oftenly used and they both work. To generate the algorithms, we need to know kind of like a couple of concepts before we can start using them. The first concept, which we're going to use it for the rest of the course, is called a variable. A variable is essentially an identifier, a block that you reserve in the RAM, random access memory, of the computing device. When you reserve that block, no other program can access it, and you're basically gonna use that specific block to store some data. It is like you reserving a hotel room, and when you do that, you're gonna use it during the runtime for a value that you don't know. Now this is very interesting. A variable is an identifier that you're gonna store, but you don't know the exact value of it. You only reserve the address for it. And while you do not know what data to store, you know the type of the data. Like, it is like when you ask someone their age. You can ask a person, how old are you? But the answer is not going to be a series of characters, or the answer is not going to be a decimal number, such as the person is not going to tell you, oh, I am 22.5 years old. They will either say 22 or 23. In this case, you know that the variable is an integer number, which means it's a natural number. So, to summarize, a variable is a concept, an identifier that we store in the RAM of our computer, and we access it during the runtime of the program to store data in it. Variables are quite often used in the computer algorithms as well as in programming. This is kind of like the first concept that you usually learn. You can define your variables, you can give them any names as long as you follow some rules. The name identifiers can be named by you you can give them any name basically. But usually we follow to give them meaningful names. And we need to follow these four rules. Such as when you define a variable name, you cannot start with a number or dash. So it is possible that you define an identifier that is starting with a character, but it is not possible to define a variable name starting with numbers. Another point that you should really pay attention is the space in between the characters. This is a mistake that most students actually do. Whenever you create the variable names, sometimes I see that students leave a blank namespace in between. Always remember that the variable name should be like your email addresses. Whenever you want to take an email address, you don't leave an empty space. Instead, what you do is you can use an underscore, or you can write them all together so that you can put the beginning of the initial of the next word, initial, making it more readable. Such as you can see, first name of customer, each letter, each initial is capitalized for each word. This is called camel notation, and it makes the variable name readable. So the third rule tells us that there are some reserved words or symbols that we shouldn't use in the variable names, such as the star sign, the asterisk sign, has already got a meaning. It means multiplication in most programming environments. Hence, this symbol shouldn't exist in your variable names because it already means something. Finally, we usually do not use special characters in variable names other than the dollar sign, underscore, and the pound sign. So the currencies, for some reason, they are allowed to be used as variable names, although this is not a very common practice. You will, however, see the underscore quite often used in variable names, either at the beginning that you can put an underscore, or just in the middle when you need to use a blank space. Now, once we have defined the variable concept, we need to understand that there are two kinds of operations that you can do in algorithms. Most of the problems that we're going to solve out through this course will be either mathematical or engineering problems. So in this case, they will fall in one of these categories. The arithmetic operations refer to the mathematical operations. When you need to do any mathematical operation or equation, you perform an arithmetic operation in the algorithm. And when you need to take a decision or repeat a certain condition until it matches to a criteria, then you take a logical operation. Each of these are represented differently in the algorithm, such as arithmetic operations can be divided into mainly 5 categories: multiplication, division, modulus, addition, and subtraction. And as you can see, each of them will have a different symbol. Such as multiplication is represented with a star sign, division with a slash, modulus is a percentage, addition is a plus sign, and finally subtraction is the dash. We can also see the logical operations. Now, the outcome of a logical operation is either true or false. So whenever you take a logical operation, the outcome of it, rather than being a number in the arithmetic operation, it will now be a true or false case. The operations that you can follow logically is equals to, not equals to, greater than, less than, greater than and equals to, or less than and equals to. So these symbols, as you can see, is used for comparison, and if the x is equals to y or not. So this means that there are two outcomes. Either x is equals to y or not. It means true or false. This is an important point because, as you can see, these symbols actually mean something. So you need to be extra careful about how you use them. In an algebraic operation, an equal to sign will means set, which means you are assigning a specific operation. You are trying to find the result of an equation. On the other hand, when you use the logical operations, you put 2 equal to sign rather than 1, and the meaning of it completely changes. This time you are doing a comparison, which the outcome can be either true or false. To summarize, we need to look into the pseudocode as the use instruction level English-based commands that you can perform input, output, arithmetic, and logical operations. And flowchart does the same thing, but this time you use graphical symbols. Now, when we mention the graphical symbols, we need to look at what graphical symbols that we can use. Whenever we're gonna throw a flowchart, whenever we're gonna generate a flowchart as a computer algorithm, you need to select a specific template. There are multiple variations, multiple themes that you can use in flowcharts. And one of the most popular ones you'll come across is the IBM's flowchart template. This is kind of like a standard in the programming world, and the flowchart template uses, like, according to the template itself, it uses different symbols to represent the same kind of operation, such as there is a specific box for input and another specific box for output. In this course, I will stick to using IBM's flowchart template and the symbols. To draw the flowchart themselves, we're gonna also use a specific program called Flowgorithm. I'm gonna introduce you Flowgorithm in the next video, and we're gonna use it to generate our very first flowchart. Flowgorithm is actually a free application that allows you to create the flowcharts. If you want to use Flowgorithm on your computer, all you need to do is to go to Google, type Flowgorithm, download, and from the first link, if you go there, you'll see a download option. You can download the Windows 10 and or 8 version, or if you are on an older system, you can download it from there. Unfortunately, as far as I know, this program is not supported on Mac or the Linux environment. If you find a version of it that will work on a Mac or a Linux machine, please share it on the comment section and guide the other users. But as far as I know, it only works on Windows, unfortunately. Going back to the slides themselves, we're going to use Flowgorithm. The link is also provided to you on the slide, so you can go there and download it. In time, we're going to look into the structures of the algorithms and learn the symbols that we can use in the Flowgorithm. But to basically introduce you the symbols, each flowchart and each pseudocode that we're going to generate throughout this course will start with a start and end with an end symbol or the word. Sometimes this start or stop interchanges, such as we can say start, begin, or main, referring to the main function of the program. And instead of stop, you can also say end. So these are like not precisely defined words. So as long as you refer to the main part of the program, you can use any word that is listed here interchangeably. Such as you can say start, you can say begin, or you can simply say main. And the same goes for stop. The next symbol that you should learn is declare. Now declare is an important box that you're going to see as the third one. I skipped the second one, I'm going to return it back. And this symbol, we're going to use it to declare variables. So you're going to declare a name identifier, which is essentially a variable that you're going to use in the program. Before you declare variables, you cannot use them. So make sure that all variables are declared before you actually use them in the algorithm. The third box you need to get familiar with is the input box. The input box is used to input, enter, or read data. You can use these words interchangeably, just like the start and begin and main, or you just stick to one, whichever you prefer. The IBM template version of the input operation is this box itself. The output box is basically used to show or display data. You can also use the word print if you want to show it, because essentially the default input device on the computing systems is the keyboard, and the default output device on the computing systems is the screen. Any kind of operation that is either logical or mathematical is fall under the category of process box. A process box is a rectangle, and any kind of operation that you do on the computing side should be listed in this box. You can use the words calculate or set to refer to the process box. There are some examples here, but before I go there, I'm going to talk about the connector. A connector is a circle in flowchart, and it is used to connect a specific point with another, such as if you come to a certain point in the algorithm that you want to go back to a previous step, or you want to connect it to the end point, you can use a connector. A connector allows you to connect two different points, such as after calculating a process box, if you want to go to a different output box that is far away, instead of messing up the diagram and putting lines over lines, you basically use a connector indicating that it goes to a certain point and it continues in another point. So you can think of a connector like a portal that it will transfer the result of the operation to another point. You can see some examples here. You can see that whenever you want to input a specific variable, such as the variable name is R, you just place it into the input box. For assigning, you can use either an equal sign or a back arrow. All arithmetic and logical operations should be done inside a process box. Now, logical operations can also be done in the control or the loop boxes, iteration boxes, but we're going to touch to that topic a little bit later on, probably in the next video. Finally, we have the output box, which we're going to use to display data. Now I'm going to stop in here, and in the next video, I'm going to show you how you can generate the very first algorithm. Thank you for watching, and I'll see you guys in the next video. Take care.